A 660-pound robot just towed a van, and it didn't even break a sweat. You've seen robot dogs do backflips. You've never seen one that can carry your entire car and then go to work for 8 hours. No CGI. No fast forward. One take. This is Kepler at the 2026 World AI Conference. They didn't just break a record. They broke the single most embarrassing curse in robotics. The unspoken rule that four-legged machines are only good for TikTok clout and billion-dollar R&D burn rates. The moment that van moved, the entire premise of useful robotics shifted. So why should you care about a metal mule that weighs as much as a grand piano? Because this thing works. And working is the one thing the industry forgot how to do. The problem with heavy robots? It's always been physics, not software. For years, the industry accepted an impossible triangle as gospel. You want a heavy frame that doesn't tip over? Great, that eats battery life. You want a massive payload to carry industrial parts? Fantastic, that spikes power consumption so hard the robot dies in under 2 hours. You want long endurance for a full factory shift? Fine, but then you have to gut the payload capacity and build it out of flimsy carbon fiber that cracks under real stress. This wasn't a design challenge. It was a structural curse. Boston Dynamics' Spot, for all its viral fame, maxes out at about 14 kilograms of payload. That is a heavy backpack. That is not an industrial tool. Hydraulic systems from other players offer more grunt, but they leak fluid. They hate temperature swings. Maintaining one costs more than leasing a forklift. The industry settled into a comfortable, depressing consensus. Quadruped robots are for surveillance. They are for entertainment. They are for impressing VCs. They are not for moving mountains. Kepler looked at that consensus and treated it like a personal insult. They didn't iterate on existing joints. They didn't buy off the shelf. Actuators and software stacked their way to mediocrity. They went back to the drivetrain. They took the planetary roller screw linear actuators they had already built for their K2 Bumblebee humanoid. That component was designed for high-precision, high-load factory work. They dropped that entire powertrain into a quadruped frame. That choice is the atomic bomb of this story. Picture a hydraulic jack that never leaks. Now picture it moving at walking speed while holding a smart car. That's the screw. It converts rotational motion to linear motion. Friction is so low you wouldn't believe it. Rigidity is so high. The chassis doesn't bend. Servo joints, they jitter like a cheap washing machine on spin cycle. Under heavy loads, that micro vibration turns into catastrophic energy waste. It causes structural fatigue. Hydraulics give you raw power, sure, but they introduce hysteresis. They have leak paths. In a factory setting, that compromises cleanliness and reliability. The planetary roller screw is the silent killer of both. It doesn't shake. It doesn't sweat hydraulic fluid. It just pushes. And it pushes with the mechanical efficiency of a machine tool that costs $500,000. By industrializing this component, getting 80% core component self-sufficiency, Kepler made a quadruped that doesn't behave like a dynamic creature. It behaves like a milling machine with legs. And that changes everything. Now let's talk about the numbers. Because numbers are the only language industrial buyers speak. But let's skip the spreadsheets. Here's the reality. The Kirin heavy-duty platform weighs 300 kilograms on its own. That's 660 pounds of steel, actuators, and batteries. Its payload capacity is nearly 1 ton. That is not a typo. It is a 2. Zeros and pound carrying capacity on a machine that doesn't even have wheels. At the conference, engineers didn't just stack weights on it. They stepped onto the platform themselves. Multiple full-grown adults, standing together, shifting their weight, moving around. The robot's body didn't deform. No sag, no structural groan, no servo whine. It held them like a concrete slab. Then they ran the torture test. They loaded a full industrial pallet of components onto its back. They made it navigate a mock workshop. Starts, stops, turns, speed bumps. The load didn't shift. The gate didn't wobble. And then, for the grand finale, they attached a tow cable to a full-size commercial vehicle. They dragged it across the exhibition hall. That image, a metal dog towing a van, is the visual thesis of the entire presentation. It tells you, without a single line of marketing copy, that this machine is not for dancing. It is for displacing mass. Pure and simple, the dark secret of electric quadrupeds is thermal runaway. When you load them up, the motors pull current. The controllers heat up. The battery management system starts throttling performance to prevent a fire. That's why most demos are short. That's why they show the robot walking for 2 minutes and then cut away. Kepler cracked that by managing the energy curve at the source. The roller screw transmission is so mechanically efficient that the motors don't need to work as hard to hold position. When you're standing still with a ton of weight on top, a traditional servo has to constantly fight gravity with electrical current. It burns energy just to stay upright. A screw-driven system can mechanically lock in place. It holds the load without bleeding current. 8 hours isn't a battery spec. It's a middle finger to every engineer who said you can't have heavy, strong, and long-lasting at the same time. 8 hours is not a marketing gimmick. It is the length of a standard factory shift. This machine clocks in, works for 8 hours, and clocks out. No lunch break. No battery swap. No downtime for recharging. It changes the logistics of automation from how do we schedule the robot to the robot is just another worker on the floor. That is the threshold nobody had crossed before. Name one other robot that works a full shift under max load. I'll wait. But the story gets weirder and more compelling. Look at the rideable version. This was the phenomenon of WAIC. The lines stretched past adjacent booths. People waited for an hour just to sit on the back of a 300-kilogram quadruped. They took a slow, deliberate lap around the demonstration area. Let me be cynical for a second. Riding a robot is not useful in itself. It is a circus trick. But Kepler didn't stop at look. A human can sit here. They designed it for dual-mode operation. You can ride it, and simultaneously, the rear platform carries cargo. In a closed campus factory or a sprawling industrial park, the bottleneck is often moving both personnel and supplies across rough terrain that isn't paved. You don't want to drive a golf cart through mud. You don't want to carry heavy tools by hand. The rideable Kirin lets one worker traverse 45-degree slopes. It wades through standing water. It crosses gravel and rubble. It delivers both the person and the material to the exact point of need. IP67 rated core components. It can wade through puddles that would short-circuit lesser electronics. Tri-mode positioning. Intelligent following. It doesn't need a handler to hold a remote control. It locks onto the worker and follows them like a massive, obedient mule. That is the kind of practicality that converts into real deployment. Mountain powerline inspections used to require teams of workers hiking for hours, carrying diagnostic gear, food, water, risking slips and fatigue. The rideable Kirin carries the inspector to the base of the tower. It holds their equipment. Geological surveys in remote wilderness. It carries the scientists and their rock samples back to camp. Emergency rescue in disaster zones. It is the first vehicle on site, ferrying first responders and medical supplies through debris where ambulances cannot roll. Border patrol and logistics in rough terrain. It runs regular supply routes without needing fuel depots. The conference audience wasn't just giggling because they got a photo for Instagram. They were trying to figure out how fast they could buy one. And Kepler, in a brilliantly frustrating marketing move, told them it isn't for sale yet. That unreleased but trending status is the most powerful signal of demand you can get in this industry. It means the hype is organic, not manufactured. Now, pivot to the K3 humanoid, because this is where the bait and switch happens. You watch the Quadruped and think, okay, they make heavy dogs. Then they drop the K3 Bumblebee, and you realize the Quadruped was just the lower body playbook. The K3 is a direct evolution of the K2. The K2 already logged tens of thousands of real factory hours. Not in a lab, not in a clean room, on real production lines, handling real material, for real customers. That historical data is priceless. It is the difference between a college athlete and a seasoned pro. The K2 already validated the kinematic models and the control loops. The K3 takes that foundation and refines it with one crucial addition: a waist. You might think a waist is a minor mechanical detail. It is not. It is the dividing line between a gimmick and a general-purpose worker. Real factory floors are chaotic. Workbenches are built to different heights for different workers. Equipment is positioned at odd angles to fit the flow of the line. Materials are stacked in uneven piles. A human worker adjusts their torso, twists, leans, repositions without thinking. A rigid humanoid with fixed posture is a one-trick pony. It can only work in a perfectly standardized cell. If the conveyor belt is 2 inches too high, the robot is useless. If the parts bin is rotated 30 degrees, you have to reprogram the trajectory. The K3's waist adds an extra degree of freedom. It turns a rigid joint into a flexible core. It can turn its upper body while keeping its feet planted. It can micro-adjust its reach to account for manufacturing tolerances. Tolerances that are inherent to real parts. It doesn't need the world to be perfect. It adapts to the imperfection. At the demonstration, the K3 made coffee. It took a cup, positioned it under a machine, handled the pour, served it to an attendee. That sounds like a party trick. But the hand-eye coordination and force sensitivity required to handle a fragile cup without crushing it. Those are the same skills needed to sort delicate electronic components or plug in a wiring harness. This isn't about making you a latte. It is about proving that the K3 understands contact forces well enough to manipulate objects with the same care as a factory worker. The 30-kilogram payload per arm means it can lift heavy automotive parts while still doing the fine fingertip adjustments needed for assembly. That combination of strength and delicacy is what the industry has been chasing since Honda's Asimo. But Asimo never worked a shift. The K3 is designed to sweat the wheeled version. The K3W is the pragmatic dagger aimed directly at the cost accountants. Legs are sexy. Legs climb stairs and cross rubble. But in a flat, standardized factory with polished concrete floors, legs are over-engineered. They are expensive, complex, harder to maintain. Wheels are simpler, cheaper, faster, more energy efficient. The K3W decouples locomotion from manipulation. The wheeled base does the moving. The arms do the gripping. They don't interfere with each other. The lift mechanism raises the torso to match different workbench heights. It can bend down to work on low shelves or extend up to reach high racks. In a manufacturing line, this is the workhorse. It doesn't need to impress your friends. It needs to move parts from one station to another for 8 hours straight, without asking for a raise. Kepler's decision to release both the legged K3 and the wheeled K3WW is a signal. They are not ideological, they are not purists. They are solving specific problems with specific form factors. That is how a mature industry behaves. It doesn't pick one champion. It fields an army of specialists. Now, I want to pause and talk about the commercial reality. Because if you are a cynical American viewer, and I respect that cynicism, you're asking where the rub is. China puts out flashy robotics demos every year. Some are smoke and mirrors. Some are government-subsidized theater. So let me give you the part of the story that doesn't get press releases. A factory manager in Guangzhou bought one Kirin. 2 months later, he ordered 4 more. Why? Because his workers stopped getting hernias. That's the kind of story that matters. Kepler closed 2026 with over 47 million RMB in active industrial orders. That is roughly 6.5 million USD. Not government pilot grants, not speculative purchase agreements, real money from real companies with documented repeat customers. They have deployed across 6 core industries: automotive manufacturing, precision machining, intelligent logistics, high-altitude special operations, commercial services, educational training, dozens of end users. In 2024, they built a dedicated industrial training facility. Robots run 24 hours a day, 7 days a week, simulating real factory conditions. In 2025, they moved those pilots into actual factories. They generated the data, broke the actuators, refined the software, and did it all over again. That is not a demo culture. That is a production culture. Let me give you the supply chain detail that makes this sustainable. 80% of their core components are developed in-house. That includes the planetary roller screws, the controllers, the battery management hardware. When a company relies on external suppliers for critical components, they are hostage to price hikes, hostage to lead times, hostage to quality fluctuations. Kepler owns their own production lines: Foshan, Jiangyin expanding capacity. A new 500-unit humanoid delivery center just broke ground in Jiangyin. They are not building prototypes. They are building production schedules. In May 2026, Hangzhou Kirin, a publicly listed company, announced its intention to acquire 41.57% of Kepler, up to 300 million RMB, valuing the company at approximately 722 million RMB. The stake rises to 51% post-transaction. That is not a venture capital pump and dump. That is an industrial acquirer putting real equity on the table. They audited the factory floor. They saw the numbers. The validation is not in the conference hype. It is in the balance sheet. Let me address the elephant in the room. How does this compare to American and European players? I am not going to do the tired China conquers the world narrative. That is lazy and inaccurate. American robotics has historically led in dynamic agility and AI sophistication. Boston Dynamics has unmatched fluidity. Tesla's Optimus has incredible brand gravity. But what Kepler has done differently is prioritize mechanical ruthlessness over algorithmic flair. They built a machine that can afford to be less elegant because it is more robust. The planetary roller screw is not as flashy as a hydraulic valve block with machine learning pressure control. But it is cheaper, more reliable, easier to service. In an industrial context, where a broken robot costs thousands of dollars per hour in downtime, reliability trumps elegance every time. That is not a technological defeat for the West. It is a philosophical divergence. China's robotics sector is pivoting to pragmatism because the Chinese domestic market demands it. The factories are huge. The labor force is aging. The margin for error is slim. The robots that survive there are the ones that don't break. The K3's waste upgrade, in that context, is a masterclass in listening to the factory floor. It wasn't invented in an academic paper. It was added because the K2 could not reach certain workstations on a specific automotive line. The engineers observed the problem, designed the waste, tested it for 6 months, validated the improvement. This is incremental, data-driven design. It is the opposite of Silicon Valley's move fast and break things. It is move carefully, measure everything, and release when it survives the real world. That approach is less exciting, but it is infinitely more sustainable, and it is exactly what the industry needs. We have had 10 years of flashy robotics demos that cannot survive a week in a factory. The next 10 years will belong to the companies that have dirty hands and real maintenance logs. Consider the thermal management on the Kirin. To achieve 8 hours of continuous heavy load operation, you don't just need a big battery. You need a battery that doesn't overheat and motors that don't cook themselves. Kepler's engineering team optimized the cooling channels around the roller screws. They integrated a liquid thermal management system that is surprisingly compact. The system pulls heat away from the high-load joints. It dissipates it through the chassis itself. This is the kind of invisible engineering that never makes the marketing deck, but it decides the robot's lifespan in the field. Most companies ignore thermal management until it fails. Kepler made it a primary constraint from day one. That is why their demonstration was not a 30-second sprint. It was a sustained, monotonous, boring display of reliability. And boring reliability is exactly what industrial managers find attractive. Let me also break down the rideable's traction control. When a 300-kilogram robot is climbing a 45-degree slope with a human on top, the center of gravity shifts constantly as the rider leans. The control software has to predict those shifts. It adjusts the foot placement in real time, without overcorrecting and tipping backward. Kepler uses a predictive gate algorithm that processes acceleration data from the foot contacts. It adjusts the stance width dynamically. It looks effortless, but it is computationally equivalent to balancing a stack of plates while running. The fact that it handles this with a payload of nearly a ton means the structural margins are enormous. They overbuilt it, and overbuilding is a luxury in heavy industry. It means the robot can handle shock loads, edge cases, operator error without snapping a leg. That is the difference between a research platform and a deployable asset. Now, let's return to the K3W for a moment. I think it is the dark horse of the entire lineup. While everyone is obsessed with the walking K3, the wheeled version is the one that will sell in volume. Standardized factories do not need stairs. They do not need rubble. They need a durable base that travels at high speed between workstations. The K3W's wheelbase is stable, low maintenance, inexpensive to manufacture. Its lift mechanism increases the operational envelope without adding the complexity of a walking knee. If you are a factory manager looking at a spreadsheet, the K3W has a significantly lower total cost of ownership than the legged version. Kepler knows this. That is why they did not neglect it. The dual-pronged humanoid strategy, legged for non-standard, wheeled for standard, reveals a product management discipline that is rare in robotics. Most companies chase the high-margin, high-visibility product. They neglect the boring one. Kepler is betting that the boring one will pay the bills, while the cool one builds the brand. The 47 million RMB in orders is not evenly distributed. I have been told, on good authority, that a significant portion comes from logistics and precision machining customers. Those industries have high margins and high pain points. Moving a machined automotive subframe from one cell to another is hard. It requires lifting, precise placement, avoidance of collision with expensive tooling. The Kirin's flatbed configuration allows a machined part to be strapped down and carried without a custom fixture. That is a huge win over drones or AGVs. AGVs have limited floor interaction. The Kirin can step over cables, navigate around pallets, stop exactly where the operator needs it. This solves the last meter problem of factory logistics. AGVs are good for the main aisles. The Kirin is good for the cluttered, chaotic cells where human workers currently do the heavy carrying. Let me address the potential downside, because a balanced perspective is important. The Kirin is loud, not deafening, but noticeable. The roller screws and motors produce a distinct mechanical whine under load. In a noisy factory, that is irrelevant. In a quiet commercial environment, it might be a nuisance. Kepler will need to work on acoustic dampening if they want to deploy in retail or office settings. Also, the 300-kilogram weight is a double-edged sword. It provides stability, but it means the robot is immobile if the battery dies. You cannot lift it into a service van. You need a crane. The support infrastructure for these machines is heavier than the machines themselves. Kepler is addressing this with industrial-grade charging stations and maintenance pits in their deployment sites. But for small-scale users, the infrastructure barrier is real. This is not a consumer product. It is a heavy industrial asset. The industry significance of this launch, however, cannot be overstated. For 5 years, Western media has framed the Chinese robotics push as a copying exercise. The narrative was, America innovates, China scales. But Kepler's planetary roller screw, actuator, is not a copy. It is a deliberate adaptation of a technology that predates the entire modern robotics industry, applied at a scale and cost point that no Western company has attempted. They lowered the cost of precision linear actuation through vertical integration and volume manufacturing. That is not copying, that is execution. It is the same playbook that Tesla used with electric vehicle batteries. Take existing chemistry, optimize the manufacturing, undercut everyone on price while matching performance. China is doing that for robot drivetrains, and the rest of the world is either ignoring it or underestimating its implications. The 8-hour battery life is another case in point. It is not revolutionary battery chemistry. It is revolutionary system design. Most engineers assume you need a huge, heavy battery pack for an 8-hour quadrupeds. Kepler used a moderately sized pack and optimized every watt consumed by the actuators. The efficiency gain comes from the mechanical transmission, not the power source. That is an underappreciated point. In the American robotics ecosystem, the trend is to add more compute and more power. Kepler's went the opposite direction. Reduce mechanical losses first, then size the battery. It is a hardware first, software second philosophy, quintessentially Chinese in its pragmatism. It works because hardware is hard, but once you solve it, it stays solved. You don't need to recalibrate physics. The ride experience at WIC was described by attendees as surprisingly smooth. The legs absorb shock through a passive compliance mechanism integrated into the lower joints. It is not active force control. It is mechanical springiness that dampens vibrations from the floor. This means the rider doesn't feel every pebble. The gate is designed to prioritize stability over speed, so the ride is slow. Top speed is only about 3 miles per hour. This is not a dirt bike. It is a walking platform. The speed is appropriate for navigation and material handling, but it does limit the use case for large campuses. If you need to move a person across a mile-long factory complex, a golf cart is faster. The Kirin shines when the terrain is bad, not when the distance is long. That is a critical context that most viral videos miss. The robot is not replacing vehicles. It is replacing hiking. The K3's coffee-making demonstration is also a bit of misdirection. It is not about coffee, it is about force control. The K3 has joint torque sensors that measure the resistance at each motor. When it grips the cup, it monitors the reaction torque. It stops tightening the moment the cup is secure. This prevents crushing. On an assembly line, the same technique prevents it from over-tightening screws or crushing delicate electronic housings. The servo control bandwidth is high enough to react to sudden forces within milliseconds, meaning if a human bumps into the robot, it softens the impact, rather than fighting back. Safety is a huge concern in human-robot interaction. Kepler's torque control architecture is designed to limit force output to safe thresholds. That is the unsung hero of the K3. It is not just strong, it is gentle when it needs to be. Now, let's talk about the long-term play. Kepler's investors are not looking for a quick exit. The 722 million RMB valuation is based on the thesis that industrial robotics is about to become a multi-trillion-dollar market, and the winners will be determined by manufacturing capability, not software patents. By securing 80% self-sufficiency, Kepler is building a moat. If tariffs or supply chain disruptions hit, they can still produce. If component prices rise, they absorb the margin. That strategic independence is rare in China's hardware sector. Many companies rely heavily on imported servo motors and reduction gears. Kepler designed their own reduction mechanism through the roller screw. They are not subject to Japanese or German gearbox shortages. That is a competitive advantage that will only grow as volumes expand. The export potential is enormous. The K3 and Kirin are designed with global safety standards in mind. The IP67 rating, the torque safety limits, the battery certification, all compliant with international norms. Kepler has not announced US distribution yet, but I can guarantee that American factory groups are already making inquiries. The price point, though not officially disclosed, is rumored to be competitive with mid-tier industrial AGVs, surprisingly affordable for a humanoid or heavy quadruped. If they price it right, it will undercut the cost of a specialized stationary robot arm, while offering far greater flexibility. That is the killer application. A robot arm is fixed to a bolt. The Kirin can walk to the task, do the task, and walk to the next task. That versatility is what factory managers have been dreaming of since the 1980s. Let me conclude with a larger observation. The robotics industry is transitioning from the show phase to the go phase. The show phase is about agility, dexterity, viral videos. The go phase is about durability, cost, uptime. Kepler has shown up to the go phase with a product portfolio that is ugly, practical, and robust. It doesn't dance. It doesn't do backflips. It tows vans and carries pallets. That is the future. A future where robots are not celebrities. They are workers, where they get dirty, break down occasionally, get fixed, and go back to work. That is not a downgrade. It is a maturation. And if you are paying attention, you will see that this maturation is happening faster in China than anywhere else. Because the demand is immediate. The factories are there. The labor shortage is real. The economic imperative to automate is stronger than the cultural imperative to impress. Kepler is riding that wave not as an innovator of first principles, but as an executor of proven principles at industrial scale. That is the untold story, not the singularity, not artificial general intelligence, but the ordinary, everyday magic of a machine that can hold a ton without bending, work a full shift without sleeping, follow a human through mud and gravel to deliver supplies exactly where they are needed. That is not sci, that is logistics. And logistics is what runs the world. Kepler has turned the corner from making toys to making tools. The rest of the industry is now playing catch-up, not because they lack brilliant engineers, but because they have been optimizing the wrong metric. They optimized for grace. Kepler optimized for grit, and in a world that needs to move massive things over broken ground. Grit will win every single time. That's not a movie trailer. That's Tuesday at a factory.